All right, let's dive into something kind of mind-bending. There's this incredible new paper from Google DeepMind, and it completely flips the script on how we think about AI. The big question is, what happens when we stop building AI ourselves and instead use AI to design even better AI?
So, we're all used to seeing AI beat the pants off of us at our own games, right? I mean, poker, Go, the best human players don't stand a chance anymore. But what if that's just the beginning? What if the real game changer isn't just an AI that can play the game, but an AI that can redesign the rules of how learning even works? That's exactly the wild idea these researchers went after.
Okay, so before we get to the really cool part, the solution, we've got to understand the problem they were trying to solve. And it turns out the biggest thing holding AI back, well, it's been us, humans.
See, right now, designing a really cutting-edge AI algorithm is, well, it's less like precise engineering and a lot more like being an artist. Researchers are staring at this massive, almost infinite landscape of possibilities. They have to rely on their gut, their intuition, and a whole lot of slow, painful trial and error. The paper has a fancy name for it, manual iterative refinement. But really, it just means we're stuck, limited by our own creativity and, let's be honest, our patience.
And this is pretty much what that process looks like. You start with an algorithm that already works pretty well. Then, a brilliant researcher has a spark of genius, an idea for how to make it better. They'll spend weeks, maybe even months, coding it up, testing it, only to find out, nope, didn't work. Back to square one. You can see how this becomes a massive, massive bottleneck.
So what's the answer? How do you smash through that bottleneck? Well, the idea is as brilliant as it is radical. What if you take the human designer and just take them out of the equation? What if you let an AI do the discovering itself? This isn't just a small step forward, it's a whole new way of thinking.
And that's exactly what the team at Google DeepMind did. They looked at this problem and said, we're not just going to speed up the old way of doing things, we're going to invent a brand new way. And here it is. Their creation is called AlphaEvolve. Now, the really crucial thing to get here is that this isn't just an AI fiddling with a few numbers or tweaking some settings. No way. This is a system that uses a large language model, an LLM, to go in and rewrite the actual code of an algorithm. It's treating the code like DNA, intelligently mutating it to create totally new species of algorithms.
The real magic, the secret sauce, is in how it makes those changes. See, people have tried this before, but they usually just made random changes to the code, like flipping bits or swapping lines. And guess what? It almost always just broke everything. AlphaEvolve is different. It uses an LLM that actually understands the logic of programming. The paper calls it semantic evolution. So think of it this way. The old way was like randomly changing letters in a sentence. You'd mostly get gibberish. AlphaEvolve is like having an expert editor who reads the sentence, understands what it's trying to say, and then rewrites it to be clearer and more powerful. Okay, that all sounds amazing in theory, right? But the big question is, does it actually work in the real world? So, for its first big test, the team pointed AlphaEvolve at a really foundational type of algorithm, the kind used to master games where you don't have all the information, like poker. This family of algorithms is called counterfactual regret minimization, or CFR for short. And the idea behind it is actually pretty intuitive. Basically, the AI plays a game, and after every single move, it looks back and calculates its regret. It's kind of like when you're playing and you think, if only I'd bet more, I would have won so much more. That if only feeling, that's regret. And the AI's whole goal is to minimize that feeling over and over across millions of simulated games until it learns the absolute best way to play. So what did AlphaEvolve spit out? This, a brand new algorithm called VAD-CFR. And honestly, it's just weird, in the best possible way. It does things that a human designer would probably never even think to try. For example, it learned that when the game gets really chaotic, it's actually better to forget your past mistakes faster. And get this is the wildest part. For the first 500 rounds of the game, it doesn't even try to form a strategy. It just watches. That totally goes against our human instinct to always be learning and improving from the get-go. And the results? Whoa, they are just stark. This chart is showing something called exploitability. Basically, it's a score of how easy it is for an opponent to find a weakness in your strategy. So a lower score is way better. And just look at that.
The AI-designed version, VAD-CFR, isn't just a little better, it's more than twice as good as the best human-designed algorithms. It just creates a much tougher, more solid strategy, and it gets there faster. Okay, so that's one heck of a win. But was it just a fluke? A one-hit wonder? To prove this thing was the real deal, the team pointed AlphaEvolve at a totally different kind of problem, a completely different class of algorithms.
This time, they looked at a family of algorithms called PSRO. Now, the easiest way to think about PSRO is like it's a private training league for AIs. You create a whole population of different playing styles or strategies, and then you just make them play against each other nonstop. Each one is constantly looking for weaknesses in the others and learning how to exploit them. The end result is that the entire population, the whole league, just gets stronger and stronger over time.
And you guessed it, AlphaEvolve delivered again. It came up with another completely novel solution, this one called SHR-PSRO. And just like before, its approach is incredibly smart. It creates this kind of hybrid strategy. It blends a super stable, reliable way of playing with a much more aggressive exploiting style. But here's the genius part. It dynamically changes that blend as it learns. It starts out exploring all the possibilities, and then, as it gets smarter, it shifts gears to ruthlessly exploit the weaknesses it's found. The result? Just as impressive. The AI-designed version finds better solutions, and it gets there way faster than the standard methods. It's more efficient, it's tougher, and remember, it figured all of this out completely on its own.
So let's take a step back. What does all this really mean? We've just seen two different examples where an AI discovered brand new algorithms that are flat out better than what humans came up with after decades of research. This isn't just about making games harder. This is way, way bigger than that.
What we're looking at here is a fundamental shift in how we even do science. AI is changing from being just a tool, a fancy calculator that we use, into a genuine creative partner. A partner that can come up with totally novel ideas, things that our human intuition might have never stumbled upon. The researchers who wrote the paper said it perfectly. The future here isn't humans versus AI. It's a collaboration. It's about combining our human ingenuity with this incredible new power of AI-driven discovery. Together, we can start tackling problems that were just impossible before. And that really leaves us with this one massive, thought-provoking question. We just saw this work for game theory algorithms. But what happens when we aim a system like AlphaEvolve at the other great scientific mysteries? Things like designing life-saving medicines, or discovering new materials, or even uncovering new laws of physics. What huge, unsolvable problems are we on the verge of finally cracking? Together.